We present PlenopticPoints, a novel point-based neural rendering approach for complex real-world objects. Recent approaches extend on the ideas introduced by NERF to achieve improved performance in terms of image quality, optimization time, and rendering speed during inference. In this work, we use a point-based representation which enables us to replace the commonly used combination of ray marching and volume rendering in favor of rasterization. In addition to faster rendering compared to purely MLP-based methods such as NERF, a point-based representation can explicitly model local details such as fine geometry and high-frequency texture. To model an object of interest, our method requires multiple RGB images as well as the corresponding intrinsic and extrinsic camera parameters. As we are not interested in modeling the background of the scene, our method furthermore assumes the availability of foreground segmentation masks. Initially, we create a regular grid inside the scene's bounding box and place a point at each of its vertices. We then iteratively remove points located outside the visual hull defined by the foreground masks and attach a scalar opacity value as well as a set of shading features to each remaining point. To render an image, we then employ a multi-step neural rendering pipeline. For a given viewing direction, we use spherical harmonics shading to convert the high-dimensional but view-independent feature vector of each point to a lower-dimensional view-dependent representation. We then use Pointsfor, a differentiable sphere-based rasterizer, to convert the view-dependent point cloud to a two-dimensional feature map. To obtain an RGB image, we use a deep neural rendering network with a customized UNet architecture that is furthermore responsible for hole filling. When optimizing a model, we render a full image in each iteration and optimize point opacity and shading features as well as UNet weights. We furthermore implicitly regularize our model through random point dropouts and the addition of a small amount of noise to the point positions. For the loss function, we combine an L1 loss, a perceptual loss, and add multiple regularization terms. Please see our paper for details. To evaluate our approach, we perform two main experiments. In the first one, we use the synthetic dataset created by the authors of NERF. For each scene, we initialize a model using about 4 million points, optimize for approximately 2 hours, and achieve around 7 frames per second during inference. In terms of novel view synthesis, we observe improved representation of fine geometric detail as well as reflective surfaces compared to current state-of-the-art approaches. See, for example, the more convincing quality of these drumheads. Or the slightly better looking plant pot in this scene. Overall, our method performs slightly worse in terms of per pixel metrics, but outperforms state-of-the-art approaches in terms of perceptual metrics. In the second experiment, we use 4 scenes from the Common Objects in 3D dataset. It contains image sequences of real-world objects from various categories, including camera parameters and segmentation masks generated by state-of-the-art techniques. We use these segmentation masks to remove the background in each scene. In addition to the observations from the synthetic experiment, we find our approach to be more robust to the imperfections of real-world data. See how our approach more convincingly represents reflective surfaces as present on this car. or the object boundaries of this plant with high geometric complexity. In addition to improved novel view synthesis, our explicit point-based model comes with the major benefit of supporting fine-grained scene editing. For example, we can easily remove the ground plate from the Lego scene or rearrange the metal balls in the materials scene using arbitrary 3D modeling software. In this last example, we chop off the top of the plant in the ficus scene. This concludes the video on our point-based approach for novel view synthesis. Please see the paper as well as the provided supplementary material for details.